Hi, this is Muhammad now, and my teammate is Vyoma Desai. So right now I'm going to explain ICP5 execution and followed by Vyoma for the second one. So first I was inputting the necessary libraries, NumPy, Pandas, visualization, the machine learning libraries, and then I was reading the training data and the test data. So I mounting, and then I was reading this data, and then I was to get the more information about the data set. I was just printing this. I was just using info method, so I'll be getting the data. So the description, so the information of this data, and then I was printing the first 5 rows of the data by using head function, and then also I was printing the describing the data. So like the mathematical notations like standard deviation, count, mean, everything. So it can be found by describe method. And then here finally here I will be finding like correlations between the features and then the from target class survive. So here you can see for each one software printing I'll be getting this the correlations for the features with for the survive class with respect to each feature. So here I will be comparing the correlation. I was finding the correlation between the patch feature and then survive, parent children feature and then survive. So here you can see. So for a unique data, you can see the survey method. So as per the question, is this do we need to keep this feature means we can say absolutely it's not required. Why means because here you can see the correlation is very less when compared to the 6 and then P class. So most probably we cannot use this feature as when we can say whenever the correlation is high, then we will be considering that one as a major feature. So here it is very less, so that's why we will be not considered. Then I was counting the unique data for the feature like survived so by using the value count. For the same thing for the patch also. So as you can see by the visualization. So and then the next I was visualizing this data by using the histograms. So here you can see the survived on the row I will be taking as X column, I will be taking as path. So here you can see the visualization and then visualization by using the scatter plot. I will be using the rows for like embarked and then survived. So and then here scatter plot here the x column sorry x will be x-axis will be age and the y-axis x-axis will be age and then y-axis will be p class. So here you can see the visualization, and then by using bar plot the same thing x-axis and y-axis and then bar graph. And the next what will be I will be doing the data processing. I mean the data cleaning I will be doing here. So actually what to implement the models for assume we need to have like numerical data. So if you are this data like we'll be having like categorical data, and then this will be not be most appropriate for this model. So that's what we'll be doing. I will be dropping these features from this data set, from this train data and test data. So and finally I'll be taking into combine into a list known as combine, list defined combine. And then here I was checking. So after dropping the features, so I was finally checking my data and then the null values. So by using is null method, I was checking. So here you can see age is having 177 null value. So I will be replacing these null values for age and ember, age and fair and ember. So here you can see. So what I'll be doing, so I will be replacing this age with the mean, and then for fair, median, and then embarked with the most repeating value. So here you can see for the most repeating will be to find the unique data with most repeat count, like I'll be using value count. So you can see, yes. And then finally I was mapping the data. As I told you, if I implemented this model we need to have numerical data. So I was mapping numerical, finally validating it after doing pre-processing. Here you can see, so you don't have any null value. So finally I was processing this data into new CSV by using the to underscore CSV function. I was doing this, and finally the data will be pre-processed. The data will be generated, and then here what I will be doing, I was creating the confusion matrix for this train data. So here what I will be doing is, so I will be converting this pandas data into the train into the numpy array. So here you can see, and then I was printing the data, checking the data, and then for more info about this data. Then I was taking the data in the x-axis. I was excluding the survey target class, and then y label I'll be taking only the target one for implementing this model, like in fitting the data. First we'll be fitting the train data, and then by using this train data, we'll be predicting the survey class by using the train data. So you can see splitting data by using the train test split function, and then finally I was implementing the model, and then here I will be finding the confusion matrix. So here you can see the Gaussian. So I was creating the Gaussian Navi base object, and then I was fitting this data. So finally I'll be fitting this data by passing them trained data. So here in the model, my train data will be stored, and then by using this train data, this model I will be predicting on the test data. So finally we'll be getting prediction. So by using the prediction data and my actual test data, whatever I had split it from the training data. So finally I will be printing the confusion matrix. And then again, from the same way, we'll be implementing the same thing for multinomial. So I can execute that. Okay, no problem. For the multinomial, for the other types of Navi base, I was doing the same thing. So you can see the confusion matrix, and also I was finding the accuracy for the Navi base, and then SVM, and then I was reporting the accuracy, and finally for the KNN, and I was reporting the accuracy. So whatever after the pre-processing I had done was I downloaded this data, and then I created separate notebook to find the accuracies of this pre-processed data. So I was importing this data, and then so I was importing the libraries, and then reading this pre-processed data, and then by using the info function, I was analyzing more information about this data, and then finally I was training this data. For the first, I will be dropping the survey class from the preprocessed train data, and then the y label I will be taking as the target class. Similarly, for the X test, I will be removing. It doesn't have much impact on the data, so that's why I will be dropping the data. And then finally, I will be finding the accuracy by using KNN method. So here the same way I was creating a KNN classifier object by taking cluster 3, and then training the model using the fit function. So finally I was predicting the data. I was predicting this data on the X text. So here I was calculating the accuracy. So you can see with KNN accuracy 83.95. Similarly for the SVM 68.24 I had found, and then the same thing again, Gaussian Navi base method 77.67, and then multinomial, and then finally Bernoulli. So and then so this is the implement, and the second is followed by the Prema. Thank you.